Hello, differential equation students, and welcome back to the last section of unit number 4. Okay, and this is going to be 8.3, and now all of a sudden we're going to introduce non-homogeneous systems of differential equations. We're going to continue to use the matrix method and use matrices with our characteristic equations to solve these. All of a sudden, though, now I implement a non-homogeneous part, which of course means that my E of t's, like this thing here, right, is not the zero matrix. Okay, is not the zero matrix, and that of course makes it non-homogeneous. And what we're going to do is what we've done in the past, which really just break this down. We're going to find our homogeneous solution, then we're going to find our particular solution, and then finally we're going to say that it's the homogeneous plus the particular. Okay, and this is just a little bit different with matrices, but hopefully it won't be too bad here. So getting into it, we have our A matrix sitting right here, right? Using this to create the characteristic equation, which we've done many times, right? I know I'm going to find the determinant of it, so I might as well just write that too. I'm going to take that 4 minus my lambda. Then I am going to take the 1/3 minus 0, essentially. Remember that it's the identity. Then I have 9, and then a 6 minus lambda. Okay, and of course, when I'm doing that, I get, let's see here, that's 24 minus 10 lambda plus lambda squared, and then it'll be a minus, right? And 9 times 1/3 is 3, which gives me this lambda squared minus 10 lambda plus 21 then, which creates a couple lambdas after we factor, right? Lambda 1 would be 7, and lambda 2 would be 3. So that's not too bad. So I have these lambdas, right? Which then means I have to take, like, so I say if lambda 1 equals 7, then, right, and we plug this thing in, and we would have a -3 here, a 1/3, a 9 still, and then a -1 times some big K equals 0, which creates this like 9k sub 1, and that's minus k sub 2 would equal 0, which means this is 9k sub 1 equals k sub 2. If I let k sub 1 equal to 1, then k sub 2 would be equal to 9, which gives me a big K sub 1 equal to 1, and then a 9. And remember, of course, these are tied together, right? Those two things are tied together. That wasn't terrible, hopefully. Hopefully you remember doing those, and we're pretty good at them now. Now, if lambda sub 2 equals the 3 that we were talking about, then I would have 1, a 1/3, a 9, and a 3, right? Times some k equals 0. Of course, this is k sub 2. Well, kind of working this out, I don't want to deal with the top one just because there's those fractions in there. So I have 9k sub 1 plus 3k sub 2 equals 0. Doing a little bit of solving here, I'd get 3k sub 1 negative equals k sub 2. Right? If I let k sub 1 equal 1, then k sub 2 equals a -3, which means k sub 2 is equal to 1 and a -3. And just another reminder here, these two are now tied together, right? Now this, what we're going after here this whole time, is I'm basically just assuming that this section right here is a big 0, right? That's just a 0. So when I go through, I am creating the homogeneous equation or solution, which would be the C sub 1 times big K sub 1, which was 1, 9 for me. And that was e to the alpha sub 1, or not alpha, sorry, lambda sub 1, plus C sub 2, K sub 2, and then that's e to the lambda 2. Now, that's just the homogeneous, right? And we've done that before, so hopefully we're decent at that. Now, the thing is I highlighted this and I said this part up here was 0, right? But in actual reality, we know that that's not 0. Okay? We know that it's not 0, which means I have to tackle this. Okay? Well, you can see that if it's of this form, right? I have this 2 by 1 here with an e sub t, then it should kind of follow that when I go to try to find the particular solution, then it should kind of follow that big X sub p would be equal to like some constant here and some constant there times e to the t, right? Because how else would I get those? Okay. Which here, this is really simple. If I were to take the prime of my particular there, I would still just have a sub 1, b sub 1, and e to the t, because this e to the t doesn't have anything more than a 1 up here, right? And what we did before with particulars is we plug them in, right? We take them and we plug them in. So I'm taking my prime that I just took, and I'm plugging it in there for x, and I'm taking my original one and I'm plugging it in or here for x prime and then here for x. Which, if I do that, I would have a sub 1, b sub 1, e to the t equals, then I had a 4, a 1/3, 9, a 6 for my a, then it was, oh, x, so this is a sub 1, b sub 1, e to the t, plus this -3, -10, don't forget that this is not 0, so we have to include it. And from here, see how well I can do this. Maybe I'll get the highlighter, in fact. From here, what I want to do is I want to go through and I want to grab, like this is the first thing, right? Well, it's that with this, and then, okay, here I have to be careful. This gets turned over on its side and I have to multiply it by these two, and then by the e, and then I finally have a -3 with the e. So what I'm going to do is I think I'll kind of erase this and I'll go one at a time now since I've laid it out already. Give me, let's see, what color do I want? The green here. So I start here. I have a sub 1 e to the t, right, equals, this would be a 4 times a sub 1, so that's 4a sub 1. It's a -1/3 times b sub 1 plus 1/3 b sub 1. Now these both are getting multiplied by this e to the t, right? And then I have a -3e to the t. Okay, that's just for the first line, right? The first line's here. Of course, I have another line, right? I have this second row. So that's b sub 1 e to the t, which equals, okay, now it's 9 a sub 1 plus 6 b sub 1. That also would get the e to the t, minus that 10 times e to the t. Of course, what most students, I think, end up seeing happen is like this e to the t, e to the t, e to the t don't really matter, right? Because here down here, they're all going to cancel out too, right? Which really leaves me with a sub 1 equals 4a sub 1 plus 1/3 b sub 1 minus 3. b sub 1 equal to 9a sub 1 plus 6b sub 1 minus 10. And now I just have a little system, right? Essentially, I just got a little system here. I should be able to solve it, decent. If I wanted to bring this a over, maybe the 3 across, that'd be 3 equals 3a sub 1 plus 1/3 b sub 1. Which, if you really hate the fraction even, you could actually multiply everything by 3. So then this would be a 9 equals 9a sub 1 plus b sub 1. And then this one down here, same type of thing going on. I'd have a 10 equaling, well, that's a 9a sub 1 plus 5b sub 1. I see that these match already for me, which means all I have to do is take these two and subtract the equations, right? So I'd have a -1 equals, what, a -4 b sub 1, which implies that b sub 1 is equal to 1/4. If I know this, I can plug it back in, I don't know, to right here. That'd be 9 equals 9a sub 1 plus 1/4. Subtract a fourth, that'd be 35/4 equals 9a. Divide, I have 35/36 equals a sub 1. I have found I got both of my they're not even arbitrary. I have both of my missing constants inside of my particular solution, which I claimed was this at the start, right? So what I end up doing is then I say that the particular is equal to 35/36, this is 1/4, and that's e to the t. Okay, well, I know my final answer is going to be the homogeneous plus particular, which then means that this is big X equals c sub 1, 9 e to the 7t plus c sub 2. My k was 1 -3 e to the 3t plus then this particular, which 35/36, 1/4, and that's e to the t. And I have my solution. Okay. This is the first video. I am going to show one other video, okay, another video. In this section with the non-homogeneous ones, I'm not going to get into 3x3s. So I have one more video with another 2x2. And this next video, I might end up trying to do some initial values with it.